Hello there, this is video 4.7, congruent and overlapping triangles. All right, so in this lesson, we're going to notice that you have one vocabulary word. It's just representation. It's just a way to display or describe information, and we can use representation to present mathematical ideas and data. And in this lesson, we're going to use congruent corresponding parts of one pair of congruent triangles to prove another pair of triangles are congruent. And this involves overlapping of triangles. So we're going to have to be able to look at them and know how to break them apart and look at them as a whole, because they can get pretty complicated. So let's look at the first one. They just want us to identify what common angles does triangle ACD have versus BCE. If you notice, they share the angle C here. Okay, we could separate them, and I could go and I could do, actually, and draw it out like this. Okay, so we have A, C, D, and triangle B, C, E. And you notice that this is the angle that they both share together. So that was a pretty easy one. They just wanted to identify where did they share. So now let's start putting this together, and let's look at something that's a little bit more complicated than this. So if you look at problem 2, and I'm going to go ahead and separate these two triangles. And this is going to be Z, because the way it's written, it's really complicated. And it's a lot easier if we separate it. Okay, so we're going to pretend like I drew this so perfectly and they match exactly. So we're going to start with the given. And they tell us, and I'm not going to write it all in here. You can go back and look. And so in this section, all the given pieces right here, I'm going to write on 1. They want us to prove, and what we're trying to prove, I'm going to do it in blue and I'm going to circle, is that this is congruent to this. And so technically, if you look at this, all I did is I separated the two triangles. All right, so let's mark what they have. So they tell us that angle ZXW, which is this angle here, is congruent to angle YWX, which is here. Then they tell us that ZWX, which is this angle, is congruent to YXW, which is this angle here. So far, we've got two angles. In order to make this is true, I have to have a side, because a third angle is not going to help. We know because of the third angle rule, the third angles are congruent to each other, but that doesn't prove congruency. I need to prove a side before I can prove that those two sides are congruent. All right. Well, if you notice, they share WX. So I can put a tick mark here. And number 2, I can say that WX is congruent to WX because of the reflexive property. All right. So now I can say that these two triangles are congruent, because don't I have angle, side, angle, angle, side, angle? So I can say triangle ZWX is congruent to triangle YXW. Why? Because the angle, side, angle. Then now I can say that WZ is congruent to YX. And why would that be? CPCTC. And I need to make sure that they're in the same spots. So if I look at ZW, which is right here, isn't it in the same spot as YX? Yes, so they're corresponding sides. So therefore, they're congruent because of CPCTC. Okay, let's look at the next one. This one gets a little bit more complicated here. So given E is the midpoint of A, C, and BD. So I'm going to go ahead and draw this out. I believe it's something like this. And then, So we have A, G, E, and we have D, B, J, C. And what they tell us is that E is the midpoint. So we know that this is congruent and these two are congruent. So I can start with the given that E is a midpoint. I'm not going to write the whole thing out, but you would write the whole thing out and you would say the reason is given. And then 2, you could say, if you look at this as triangle ADE and, or AED, let me change this to AED. Triangle AED and triangle CEB, I can see that this whole thing are congruent, right? So I can say angle AED is congruent to angle BEC. And that's because they are vertical angles. So if I look at that big triangle, so I have a side, angle, side, side, angle, side. So I can now say that the two triangles are congruent. So I can say AED is congruent to angle B, or triangle BEC because of side, angle, side. I can go further and say that D is congruent to B, right? They're in the same positions. Oh, I wrote this wrong. They're in the same position, so I can say angle D is congruent to angle B because of CPCTC. PCTC. So if I look at these two triangles here, and I know it's kind of hard to see, but basically I took these two triangles out of the big picture. And we already said that this is congruent to this. And we said that this is congruent to this. What else do we know? Well, we know that this angle is congruent to this angle because they're vertical angles. So I can say that angle GED is congruent to angle BEJ because they are vertical angles. Now, if I look at these two triangles by themselves, they have the same tick marks, don't they? Oops, this needs to be a double. So I have angle, side, angle, angle, side, angle. So I can say that those triangles are congruent now. So triangle, and that's what I was trying to prove. GED is congruent to triangle JEB. Why? Because of angle, side, angle. So I had to go and use the big triangles first because of the midpoint I had two sections, two sides that were congruent to two other corresponding sides, and then I could prove that the angles in between them were congruent because they're vertical angles, and I could prove the triangles are congruent because of what? Side, angle, side. And then because of CPCTC, I could say these two angles are congruent. And if I look, those are angles inside of the triangles that I'm trying to prove. So when I pull them out, I can mark them. I already had that these two were congruent because of the definition of midpoint. And I forgot to, that actually is another, that's a step that I missed. It goes right here. So we would say that AE is congruent to EC and DE is congruent to EB because of definition of midpoint. So we needed to add that in one more step right here. So then this would be 3, 4, 5, and so on. And then I could say that these two angles were congruent because of vertical angles, and now I've got angle, side, angle, which is a theorem, so now I can say that those triangles are congruent. So we're just using overlapping and separating parts. Now, here's where the real complicated one comes in. Let's look at example 4. And this is a really complicated one. So you see they took them out. I'm going to do one more. I'm going to take one big one. Okay, so I'm going to write the A, C, E. And then I'm going to go ahead and draw these out. So you have A, B, X, D, E, and then they had one more box, something like this. D, E, and A, B, and E. So let's start with given. So they tell us CA is congruent to CB. That's the big. So that's why I wrote the big one out and took it out by itself, which the book did. That's going to be given. They also tell us that BA is congruent to DE. Okay, so again, that's all given. And in step 2, I'm going to say that these two are congruent. Okay, so angle CAE is congruent to angle CEA. Why? Because this is the basis of isosceles triangles are congruent. And that's theorem 4.1. We just got tested over. Then I'm going to say, if you notice that they share here, on this box here, that they share AE, these two triangles. So these two are congruent. So I'm going to say that AE is congruent to AE. Why? Because of the reflexive property. Okay. So what am I trying to prove? I'm trying to prove that this is congruent to this. All right, so I set AE, so I can go back and say that this is congruent to this, right? So these are separate things. And I can say that this, no, I can't say that. Yes, it's congruent to this. Yes? All right, so what do I need to say next? So I need to say that triangle BEA is congruent to DEA. So I've got enough information to say that these two triangles over here are congruent. So, because of side, angle, side. So I'm going to say that triangle BAE is congruent to triangle DEA. Sometimes you get a lot more information than you need, but in this instance, we need this. So 1 is given, 2 CAE, 3 reflexive property, 4, oh, this is going to be 4 and this is going to be 5. So 4, I didn't actually write it. We marked it. So we set angle CAE. Oh, we set it up here. Oh, no, this is right. This is right. I'm getting ahead of myself. Okay, so we said that. And we said the two triangles are going to be congruent because of what? Side, angle, side. So now I can say that angle ABE is congruent to angle EDA because of CPCTC. So I'm saying that this angle here is congruent to this angle here because of CPCTC, which is also this angle here, correct? So now I've got angle, angle, side. So now can I prove that this, I can say that this is congruent to this. I don't have to because I've already established that A and E are congruent. Correct? I already said, oh, we don't know that. That's a different, we don't know this on this one because that's actually a different one. If you notice this angle A here is not, and angle E is not the same as this and this over here. This is part of that angle. Okay, so but I can't say that these two angles are congruent because they're vertical angles. So I can say that angle ABE, or BXE, sorry, BXA is congruent to angle DXE because of vertical angles. Okay, so now I've got angle, side, angle, with the angle inclusive, angle, side, angle. So now I can say this triangle is congruent. So I can say triangle BXA is congruent to triangle DXE because of angle, angle, or angle, side, angle, side, angle. And now I needed to prove this right here. Well, actually, I have here. So I do have angle, angle, side. I'm sorry. Angle, angle, side. I'm trying to prove that BX is congruent to DE, but because DE, because of this triangle, is congruent to BA, I can mark this triangle over here. So we said that DE is congruent to BA here. Well, I can do the same thing here because they're exactly the same side. So that's why on this triangle, we've got this side is congruent to this side. This is congruent to this. And then these are congruent because of vertical angles. So I proved the two triangles are congruent. So now I can prove that BX, I can say BX, I've proven, is congruent to DX because of CPCTC. Because I've proven the two triangles are congruent. Now I've proven that the sides are congruent because of CPCTC. So it gets a little hairy when you take things out and you have overlapping triangles. So I have to remember, so here, when I took it out this way, this A is not the same as this A of the big triangle. Okay? Remember, the big A is congruent to the big E because of the base of isosceles triangles are congruent. But you see BAX plus XAE make the big A of the big triangle. Same thing over here with E. So I couldn't say that these A's and these E's are congruent because I didn't have enough information. But I had to work my way and I had to look at these and take them out. And they told me that these are congruent. And then I knew they shared AE and AE. So I had to work my way with vertical angles here, which is this over here. And then I had to prove the two triangles are congruent. Then I can say their other parts are congruent. So it can get kind of hairy and kind of confusing. You got to break them out and look at and mark. Usually you would draw them much bigger. I don't have a lot of space, so I couldn't do that. And sometimes it helps to use different colors and make sure your tick markers are appropriate. All right, so go ahead and stop the video and do problem 1 through 4 in your interactive journal, and we will see you in class.